Now, some of you who have been watching all my videos, my live streams, will remember when I was using these steel shims in the segment arrays which goes in my rotor assembly. Now, obviously steel has a reluctance, quite a great amount of reluctance in change to its state, so when it's actually magnetized by passing the magnets. And it has a massive amount of sticking. Well, I've got a stationary partial stator here. Obviously you can see the difference with this. It has very little cogging actually, but as you can see, there's very little cogging between the magnetic fields there. It doesn't, if I take my fingers out of the way, you can see it doesn't leap across. But it has a huge amount of reluctance to change. That is the main problem with it. So, but when I was using these segments, there was no there was actually no slowdown. But there's two things that could be happening with that. One is that it was already under effective load because it was the reluctance was so great in change that the amount of acceleration or deceleration when it was under an actual coil load wasn't noticeable, because when I was using these 6 of these segments on the original rotor, it was running pretty slow at about 900 RPM. We had quite a significant amount of drag on the system with these. So then I went over to using the ferrites, which were these. So I went over to using the ferrites, and these had a huge amount of sticking, quite a lot of cogging, and they weren't very efficient because of the huge gap between the ferrite there and the outside there. And I also incorporated these little tail sections to create some repulsion to reduce the amount of drag on the system. These worked fairly well, but we still didn't get the maximum. Obviously I've been through such a lot of different arrangements. As you can see, there's those with metal shims in there. I did a few of those to compare. And then I tried the shielding method, which was to use the nanocrystalline to basically block off the magnetic field as it was going around. Well, that didn't work so well because we actually lost quite a considerable amount of output. So what I'm actually going with at the moment is an alternative system where we have the nanocrystalline C-shapes, and that basically mimics the behaviour of the original steel shims, which were flared outwards like a flower, but they're going to be in one direction, so we should see a much bigger improvement. So I've only got another 2 segments of these to print, 4 more of these inserts to print, because I'm actually printing 2 more at the moment, because the 2 that I'm printing right now are for this one. Once I've got these 2 finished, I have 2 more segments to print, and then we hope that we can get a new test done for this weekend. So the reason for this being backwards to that one is because we have dual rotors now. So one of these will be on the left side, the other one will be on the right side of the dual rotor assembly. So we have this total width, so that they're actually facing like a mirror image, you can see. So I've had to print 12 of these instead of 6 because of the dual rotors, so it's taking a lot longer to make them all, and it's quite monotonous. Now we've got 6 of these ready. I've got to weigh and check the balance on them. There's 6 of these, they're going to be alternated, and I have 2 there and 2 here, and I need another 2, and then we can get them fitted in the rotor. Now these mimic the original segments that were flared out, but they're a slightly different arrangement, because let's face it, you've got to keep trying different arrangements to find the optimum design, and that's what these are. These are new design. And now obviously I can pop these cores out if I decide to go back to the this flared arrangement. I could always go back to that arrangement using nanocrystalline, but they won't be able to go so far to the left hand side, which is why I've incorporated these little bits on the edge there. So that should give a much better transition and less reluctance to change when the rotor's moving, so we should see a much bigger improvement. So I just wanted to give you an update on that. The print's nearly finished for the new cores, which are the same as these, which are going to go in there. Oh look, the printer's just finished right now. It's just this minute finished. Right, so there's my other two. They're a bit clogged up as usual. I've got to, when it cools down, I'll pop them off the bed, and I might as well turn it off actually. Right, so I've used quite a lot of material. Do you remember this thing that was full of nanocrystalline material? Well, look how much there is left. That's how much material I've used. This was absolutely jam-packed with nanocrystalline material. So there's actually a lot of nanocrystalline sheets that have gone into these segments, in actual fact. I mean, obviously there's all that lot and all that lot, and plus some of the other ones I did earlier, the other batch I did, which are still in the rotor across the room. So I've got to swap all them out, and I'm trying to recycle as much as I can, which is what I'm doing. And obviously I use a lot on the back mirror. Oh shit, the phone's flipped around again. So there's, let me just get that to flip again. So I've got a lot of reflectors on the back. Now the reason for the reflectors is it actually flips the magnetic field like a mirror, so that as the rotor is passing through, the magnetic field might be south. On this, it's hard to show you really, but it actually inverts the magnetic field as the rotor is passing by. I don't know how to show you that really. Just trying to think if I can. I'll get one of my other coils. One of my earlier coils. If I flip this nanocrystalline out of here, because it's in a slot, just take that out. Now, if you know a lot about magnetism, you know that if you put south in this side here, what happens is you have the south field moving off through the material, so you get south coming out this end, but as the magnet is passing, it actually inverts itself so that the field flips around, so that south goes out the back instead of this side, so that as the magnetic rotor is moving. So if I put this against the back of there, you can get a visual idea of what I'm talking about, that as the rotor's moving, we actually have a pivot point, a magnetic pivot, where the field flips around. So it moves the flux lines around really well, and it also reduces the amount of drag on the system. So I'm just trying to give you a rough idea what I'm talking about, but you'll have to work that out yourself, because I'm holding the phone in my hand and I can't do it with two. I can't really show you with two hands, but yeah. So you get the idea. All I know is that when I put these reflectors on the back, it actually speeds up. That's the important thing. I better put this back in here actually, if I can, so I don't lose it. Right, so my clutter is building up. At some point I'm going to have to go and disassemble all the old stuff and recycle as much as I can. This is why I didn't wind any more coils for that at the moment. I want to hold back on winding more coils until I get the magnetic field optimized, because I have to decide what gauge of wire to use eventually, and there's no point in putting winding coils and then realizing I need to change the gauge again. So I mean, that's more expense. So I just want to focus on getting the magnetic field right first, and then I can start to focus on winding the coils to suit the magnetic field. So yeah, that's just an update. Hopefully maybe Sunday I can do a test, I am hoping, but obviously I've got acetone treatment to do on the new segments that go in these holes, and that's going to have to dry out to be balanced, so it might not be Sunday. I'm trying to get there for Sunday. I'm targeting to get the other two segments, that's these things, printed today, so I can acetone them as soon as possible and get them to dry out by Sunday, you see. And the main cores, these things that pop out, these they take a while to dry out. I can pop that one out a bit. If I can get it with my finger, they're kind of tight. They're snug fit, which is good. That other one's probably going to pop out easier. Yeah, that one's popping out a lot easier than the other one. So I made these interchangeable so I could simply take them out, put new designs in if I need to do, which is the whole point of trying to keep my costs down. So instead of having to print a whole segment, I can just print the cores that go in and have different arrangements if I need to do. So the reason these are different from the previous ones is there's actually a lot bigger area for coupling. I'll show you the difference between these. The difference between these and these is the length. These didn't have segments in. If you look, there's no segment to push out on here. It's all one piece, and it was costly to print them every time. The other ones, which are actually in the rotor still, they're still in the rotor right now, but they had a shallower, the hole was smaller, right? This hole was a lot shallower, it wasn't as long. So I extended the hole to make it a lot bigger so I could get much bigger segments in there, which is why these are not going to be interchangeable with the old rotor segments that are in there, which is why I had to print all these new ones again, because these are a lot longer reaching, and I shouldn't need to redo these because the actual wall thickness up here is so thin. I don't know if you can see that, but it's about 1 millimetre. This thickness here is about 1 millimetre. It's very small gap. Makes them very fragile as well, but once the segments are popped in, they're strong. Yeah, so anyway, that's it for now. I'll keep you updated.